Let's solve this fraction. We are to evaluate the integral of y squared dx minus 2x squared dy with the parametric condition along the parameters y equals to our x squared from the origin to 2, 0. 2 on the x-axis, 0 on the y-axis, meaning the integration is on the x-axis. Now, if you check, if you integrate this, which is y, with respect to x, it will be difficult to do. Integrating x with respect to y cannot work. So you're going to work with the parametric conditions, whereby we express the parametric conditions in terms of a different variable. Because this is a parametric condition given to us, which is also in terms of x and y. So what I mean is that, so first of all, we are going to change this into, let's say, t. So I will let x equals to t. So you know, if x is t, y is going to be, replace this with t, it becomes t squared. And that will make y equals to t squared. So now x is in terms of t, y is also in terms of t. So if you look at this carefully, we have to differentiate because we are having the x, the y, which are interchanged. So let's find the integration of all of them in respect to t. So dx dt, meaning I am going to differentiate this. You get 1. Then we want to express dx, which is this, in terms of dt, so that this and this can match, meaning your dx will be equals to cross multiply 1 times dt will give you dt. Then in the case of y, okay, let's have this one also here. Dy dt equals to differentiation. This come forward to multiply. So 2t, 2 minus 1 will give you 1. So this also end here. But we can also find dy here by having dy equals to, this is multiplying this, meaning 2t dt. So now you can see that the x and the y is no more from here. Let's say if you pick the terms from here, we cannot get x and y. We are having t. So now we substitute. So you know we are going to replace y, right? Y is our y. We are having y squared. And our y is already having a t squared. So let's put the parametric here. We are going to have, okay, let's do direct substitution. So t is ranging from 0 to 2. Don't forget, this is the origin. 0, 0 will give us 0 minus 0, which will not produce any result. So we are going to begin with this. Then y is going to be t squared. Where is the y? Y is t squared. But the y is already having a square out there, so we put a square there. Then we replace dx. Where is our dx? Dx is here as what? Dt. Then minus. Don't forget, all this is affected by the same integral. So let's put our 2. Let's bring our x. Where is the x? X is what? T. And t is also going to be squared. Then let's go for dy. Where is our dy? Dy is 2t dt. So I have into bracket 2t, then dt. We can simplify this further and this to give us the integral from 0 to 2. 2 times 2 is 4. So t exponent 4 dt minus, this is multiplication, 2 times 2 give us 4. T exponent 2 times t exponent 1, addition of the powers. So give us t exponent 3, then we have dt. So here you can see that if all this is affected by the integral, we can still do it integration of difference. We integrate the first one, then we integrate the second one. So we can have the integral of the first part going to be the integral from 0 to 2 of t exponent 4 dt. You know, under integration, we increase the power by 1, divide by the result. So I'll be having 1 over 5 t exponent what? 5. If you increase this by 1, by addition, you get 5. Divide by the 5. Then our integration definitely spanning from 0 to 2. So you know, whenever I put 0 in place of t, all the result give me what? 0. So this is going to mean 1 out of 5. T is going to be replaced with 2. So 2 exponent 5 minus 0. You know, 1 out of 5 is multiplying the t exponent 5. So if you slot in the lower limit, the same 1 over 5 will multiply. If you slot in the upper limit, you get the same multiplication by 1 over 5. So this is going to mean, this will be 0. 2 exponent 5 is 32 divided by 5. That becomes the first integration for the first part. Then the second part is going to be the integral of minus 4 exponent 3 dt, which is more or less minus integral of 4t exponent 3 dt. The minus is just multiplying. So we can have that to be equals to, first thing first, increase the power, divide by the result, meaning 4 divided by 4 t exponent 4. Then we have 0 and 2. This is definitely integral. So no c to be added. So what do we do from here? This is going to be 1. So we can slot in to have t, which is going to be replaced with 2 and 0. So 2 exponent 4 minus 0. And I believe that will give us 16. So the first, don't forget we are dealing with negative. So this negative is taken along. Then we have negative 16. So now we have the first part. So in all, our integral from 0 to 2 of t exponent 4 dt minus 4 t exponent 3 dt will be equals to the first part, 32 on 5 minus, this is the minus. Then the answer is going to be minus 16. And that gives us 32 on 5 plus what? 16. What do we do here? We can also find the same denominator. So we have 1. In that case, I'll be having 5 as the denominator. When 5 divide itself, it gives us 1. 1 times 32 will be 32 plus 5, 1 goes into 5. That will be 5 times. So 5 times 16 will be 80. So this gives us, what do we get? 112, right? Divided by 5. And that in decimal will give us 22.4. Alright, I believe the concept is clear. Don't forget to subscribe, like, share, and comment. Bye-bye.